Alright, 1 second. Alright, so question number 1 is how to add positive numbers. So how to add positive numbers. Now the reason why I'm going over this because most of you don't know how to do this. So let's go over this. So when we have a positive number, absolute positive, let's see here. So for number 1 we have absolute value of 6. Those who are in class, you might as well go ahead and try to do this while I'm talking. You may finish this so I don't have to say this again. So we have the absolute value of 6, I know it's for the geometry students, plus the absolute value of negative 27. So when you have the absolute value bars, that means whatever is in the bar is going to be positive after you work it out. So for this 6, this will remain as plus 6. Plus what? Since this is a negative 27, like I said, anything in the absolute value bar will be positive. This just remains as plus 27. So we have 6 plus 27. 6 plus 27 is, oh, help me out, class. Okay, what's 27 plus 6? Very good, 33. So the answer is 33. Alright, that's how you do number 1. Now, number 2. Number 2 is 12 minus 19 in the absolute value bar. So you have 12 minus 19 in the absolute value bar. So the answer, is going to be positive after you subtract it. So 12 minus 19 is technically negative 7, but because it's in the absolute value bar, the answer is going to be positive. So the answer is positive 7. Does that make sense? I hope that makes sense to you all. Alright. Next number. Numbers 3, 4, and 5 are adding positives and negatives. I'm not going to humiliate myself and yourself by going over that. Alright, number 6 through 12 is measuring the angles. So you have to use the protractor to find the answer. Alright, but numbers 13 to 16 I'll go over briefly. So numbers 13 to 16. So it says complementary angles. What is a complementary angle? And what is a supplementary angle? Alright. Complementary angle are two angles that equal 90 degrees, and supplementary angle are two angles that equal 180 degrees. Alright. So referring back to picture for questions 6 to 12, you should be able to answer numbers 13 to 16. So for instance, when it comes to a complementary angle, for example, what angle I see as an example would be angle A delta B. So let me just write that as an example. Angle A delta B and angle B delta C will give you 90 degrees. All right. Now for 180 degrees, it could be, there's so many choices. It could be angle A delta B and angle B, and that's not B, but B delta F would be for 180 degrees. So I did one example for each. All you have to do is do another example to help you out. Alrighty. Next, it says draw the following angles with the protractor for number 17 for 22. So I can't go over that. You can go over that with yourselves. If you need help, please address KK. Don't come to me. Next is draw and graph the equation. Next is to draw and graph the equation. So we have 2 plus 2x equals y. Alright, so in order to do this, we need to have our x and y chart. So let's draw our x and our y chart. Alright, so the only reason why I'm doing this is because, anyway, let's pick some points. Let's pick 0, 2, and negative 2. You can pick any points, but it's good to have at least a 0, 1 positive, 1 negative. At least I think so. Alright, so now we gotta replace the x with the number. So we have 2 plus 2, and then replace the x with the 0 equals y. So we have 2 plus 2 times 0 is 0 equals y. 2 plus 0 is 2. 2 equals y. Alright, so that takes care of that. Next one. We have 2 plus 2 times 2 equals y. Well, we have that means 2 plus 4 equals y. Right? 2 plus 4 is 6. 6 equals y. 6 equals y. Next we have is 2 plus 2 times negative 2 equals y. So that's 2 minus 4 equals y. 2 minus 4 is negative 2 equals y. The answer is negative 2. Alrighty, now we'll prepare to draw the graph. So let's draw it. So when we draw it, put down this, put this. I'll have each line represent 2. 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6. So x is 0, this is x, and this is the y coordinates. X is 0 and y is 2, so let me use a different color to represent that. 2. Next, x is 2 and y is 6, so that's over here. And x is negative 2 and 2. So we have a line that goes something like this, alright? Fair enough. Alright, next is the numbers 26 through 37. We have an acute triangle. So an acute triangle is a triangle which all the sides are less than 90 degrees. Alright, that's an acute triangle. Next is a right triangle. A right triangle has one angle that is 90 degrees. Alright, this box means 90 degrees. Alright, that's an obtuse triangle. Now, number 29 is a scalene triangle. So with a scalene triangle, I'm trying to draw it. It's similar to an obtuse triangle, but the main point with an I know that's a horrible triangle. Hold on. The thing with a scalene triangle is each angle is a different measurement. All right. So for instance, this could be 45. This could be 75. Right. And this that could be 43, 75. And let's see what the other one should be, because a triangle should go up to 180 degrees. So 43 plus 75 is 117. 117 minus 180 equals 63. And this could be 63. And the whole purpose of this is called a scalene triangle, is because that each angle is a different degree. Next is isosceles triangle. So with an isosceles triangle, is these two angles are the same. So this could be 45 and 45. All right. So 45 plus 45 equals 90 minus 180. And then this angle could be roughly 90. But the purpose is an isosceles triangle. Two angles of the triangle are the same. All right. Now to an equilateral triangle. An equilateral triangle, all sides are the same. That's what that means. All the sides are the same. So that means each side is 60 degrees. So here's an equilateral triangle, more or less. Each side is 60 degrees. This is 60 degrees. This is 60 degrees. And this is 60 degrees. What's interesting too, this is also an acute triangle, kind of, since all the angles are, since one angle is at least less than 60. Alright, next is a trapezoid. What does a trapezoid look like? Well, a trapezoid is a parallelogram like this. Alright, so this is a trapezoid. So with a trapezoid, this side, that leg, and this leg are the same. but this bottom, this top, and this bottom, or the bases, are different from each other. The sizes are different. Next is a rhombus. A rhombus is basically a slanted square. Alright, all the sides should be equal to each other. Right, but it's basically a slanted square, more or less. Then we have a square. So square, all the sides are the same, right? And they're 90-degree angles. So they're 90-degree angles. Next is a circle. So we have a circle, and a circle is 360 degrees. Next is a rectangle. So with a rectangle, the base is the same, but the legs, and the legs are the same. All right, and they are 90-degree angles. All right, they're all 90-degree angles. And then with the line segment, what's interesting about a line segment? It is a line. This is a line with arrows. But when I ask for a segment has these points on opposing ends. And that is a line segment. Alright. Next it says find the area and perimeter. So for number 38, I gave the one side which is 3 feet. Alright? So I gave 3 feet. Now a perimeter is basically at all the sides. So if it's a perfect box for number 38, that means all the sides are the same. So we're doing 3 plus 3 plus 3 plus 3, or 3, which is 3 plus 3 is 6, 3 plus 6 is 9, 9 plus 3 is 12. Alright, so the perimeter is 12. Now we're to find the area. Area is length times width, which is 3 times 3. So that is 9. Alright, so that was easy. Next is to find the perimeter of an area of this triangle, or this right triangle. So here's the right triangle, and we need to find the area. So the perimeter, we'll find the perimeter first. So we have 4 and 6. The formula is a squared plus b squared equals square root of c squared. But since I will only use this formula if there's complex numbers, so there's nothing complex, then we just do a plus b equals c. So that means it's 4 plus 6 equals 10. So that's 10. All we have to do now is to add, since now we know what the hypotenuse is. So 6 plus 4 is 10 plus 10 is 20. So the perimeter of this right triangle is 20. Alright, now to find the area. Alright, so the area for this triangle is A equals 1/2 times base times height. So the height for this particular problem is, well, the base here is 4 and the height is 6. Alright, so we have 1/2 times 4 times 6 is 20. Now 1/2 times 20 is 10. So the area for this right triangle is 10. Alrighty. Next is number 40. Alright, so we have, well, I guess I need to draw this out for you. Hope you all visualize. Alright, so we have this rectangle that's split into 2 boxes. Alright, so that means each side, this is 4, this is 4, this is 4, this will be 4, and this will be 4, and this will be 4. Now let me add them up. 4 plus 4 is 8 here. This is 8. This remains as 4, and this remains as 4. All we do now is we just have to add them. So we have 16 plus 8, and 16 plus 8 will give us the perimeter, which is 24. Then we have to do the area, which is 8 times 4, which is 32.
Police department, you're under arrest.
Alright, next is we have to find them as the triangles for numbers 41. Alright, good. Alright, so we have this is A, this is B, and this is C. This particular angle is 45. Alright, so this will be 90. I should have drawn that triangle. This will be 90. So now we gotta figure out what this is, what is missing, what is C. So we know A is 90, B is 45, and we know in triangles is 180 degrees, so all we have to do is add 90 plus 45, and whatever that answer is, subtract from 180 and get the absolute value, which is the answer for that. So 95 plus 40 is 1350. Now when we subtract them from each other, which is 180 minus 135, we get 45. So C is 45. Alright, now for the next problem is an equilateral triangle where all the sides are the same, right? Because of each angle is, so that's an equilateral triangle. If this side is 60, then all the angles are going to be 60. So that's easy to determine. Alrighty. Alright, next is numbers 47 to 53, which is pretty easy. So I'm not going to give you the answer for each number, but I will. Let's draw the line. 10th graders are disturbing me from finishing this video. I don't know if they even want this video because they talk too much. Alright, so I gave one angle, which is number 1, and this is 30. So this is easy. Alright, we have to find the opposite. The opposite of this angle is this angle, which is 30. Okay? And then we just copy, and the opposite of this angle here would be, well, this is 30, and this is 30, and this is a straight line. A straight line is 180 degrees. So 180 minus 30 is 150. So then this is 150, and this is 150. And all we have to do is transcribe this again. If this is 30, and this is 30, the opposite would be over here, which is 30. Okay? And this would be 30. Then once again, 30 minus 180 is 150. This is 150. And this is 150. Alright, easy. That's easy. Alright. Next is number 54. Number 54 is we have this triangle, we have this trapezoid, and we have so we need to find out what the answer is, how to figure out how to find the area of the trapezoid, or what is the formula for finding the area of a trapezoid. So first thing is first, let's write down what the formula for area of a trapezoid is. The area for a trapezoid is area equals 1/2 times the height plus base 1, or times the sum of base 1 and plus the sum of base 2. Alright, now let's add them. So we have the area, 1/2. We have the height, which is 10. We have base. Well, I should have wrote two different bases. Alright, so we have base 1, which is which is 25, and then I'll make base 2. I'll make base 2 30. Alrighty. So 25 plus 30 is 25 plus 30 is 55 times 10 times 1/2. Alright, now I added 30 because I forgot to add 30. 10 times 55 is 1/2 times 550. Alright, 550 divided by 2 equals 275. The area is 275 for this trapezoid. Now for 55, that's easy. That's 1/2 times base times height for the area of a triangle. We already did that. 1/2 times base, which is 12, times height, which is 9. 12 times 9 is 72. 1/2 times 72, right? So 72 divided by 2 equals 36. The area is 36. Alrighty, next. Oh, I made a mistake with 54. Number 54, I did the area of a trapezoid. I should have wrote the area of parallelogram. I couldn't read my own drawing. Let's do those numbers again. Outside. So for number 54, it was just base times height. I didn't realize that was a parallelogram. So that's 10 times 25, which is 250. Alright, so that's the area for that. My mistake. But now that you know how to do a trapezoid, we won't have any problems figuring out how to do number 56. So number 56 is A equals 1/2 H times base 1 plus base 2. Alright, sorry about that, I made a mistake. So area equals 1/2 times the height, which is 7, times 18 plus, oh, I can't see what the other one is. Hold on, I had to use, your test may have cut off. Plus 10, there you go. Turn that off! 18 plus 10, which is 28. So we have 28 times 7. 28 times 7 equals 196. And then 196 divided by 2 equals 98. The area is 98. Alright. Number 57 is base times height, 4 times 3, 12. Area is 12. Now for the table, I can go over that verbally with you. So area is length times height for a rectangle. Square is the same. Triangles is 1/2 times base times height. Parallelogram is base times height. Trapezoid is A equals 1/2 height times the sum of B1 plus B2. And rhombus is length times height or base times height, however way you want to do it. Okay? Now, number 64 is going to take some time. So, for number 64, we need to find the area of the equilateral triangle, meaning all the sides are the same. So, we know the side equals 7. So now, let's figure this out. Alright, so the formula is A equals S squared times the square root of 3, 3 squared, excuse me. Square root of 3 is over 4. Alright, now all we have to do is fill it in. So A equals 7 squared times square root of 3 over 4, which is 49 times the square root of 3 over 4. And that's the answer because it can't be divided. I mean, you kind of could. The square, because we could do square root of 3, which divided by 4 times 49, which is 21.2. Well, either answer is fine. I'm not asking you to do that, but you would need a calculator to do that. So 29.2. Alright, so the semi-perimeter formula and Heron's formula are area of a scaling triangle. So the semi-perimeter triangle formula, and the Heron's formula. Well, I'll show you that. Well, I guess I will write everything down. So the semi-perimeter formula is S equals, the semi-perimeter is A plus B plus C over 2. Alright, this is only used for a scaling triangle. That's the formula for our semi-perimeter formula. Then Heron's formula, which is the Greek fellow, is the area is A equals A equals the square root of the following: S times S minus A, S minus B, and S minus C. Alright, now we have the following. For 67 to 68, we have 4 plus 6 plus 8 over 2. 4 plus 6 is 10, 10 plus 8 is 18, 18 over 2 is 9. So S equals 9. Now to find the area. So we have the side. So the side is 9. And then one side is 9 minus A. So we'll do 9 minus 4. Then we have 9 minus B, which is 6. Then we have 9 minus 8. Okay. Now, Seanchus, can you open the door for please? 9 minus 4 is 5. 9 minus 6 is 3. And 9 minus 8 is 1. 5 times 3 is 15. 15 times 1 is 15. So we're left with A equals 9 times 15. 9 times 15 is 135. So A equals the square root 135, the square root of 135. Alright? And then 130, the square root of 135. Let's see if we can square that. No, we can't, but we can. Let's see what numbers can factor out of 135. I'm thinking. Well, let's see what are the factors of 135. So we have 135. Let's see what are the factors of 135. 135 divided by 5 is 5 and 27. We're left with 5 and 27. And then with 27, we're left with 3 and 9. And with 9, we're left with 3 and 3. The only pair I see is these 3. So the answer is 3 times the square root of 5 times 3, which is 15. So it's 3 times the square root of 15. That's the answer for that particular problem. Alright? Next is 69 to 70. For number 69 to 70, we have this cylinder. Alright? The formula for cylinder is, the area is side equals length plus 2b. Alright, S equals the length plus 2b. I got distracted, so let's figure that out. So S equals, now because this is a cylinder, the length is going to be C times H plus 2b. Right? And then this actually becomes, because the CH stands for circumference times height, which is actually 2 pi circumference, 2 pi times H plus 2 times base, which is pi r squared for the base. Alright, so there we go. Now we can solve this. So we have s equals 2 pi h, which is the length, which is 9, that's the height, plus 2 pi r squared. The radius is 6 here, so 6 squared. Alright, now all we have to do is just fill in the data. So this becomes s equals this should be 2 pi, I messed up. This should be 2 pi RH. 2 pi RH. Sorry, 2 pi times r times h. So this becomes 2 pi times r, which is 6, times 9, plus 2 times pi equals 6 squared. Alright, s equals 2 pi times 6 times 9, which is 54, plus 2 pi times 36. Alright, that becomes equals 108 pi plus 72 pi. And then when we add them together, we get 180 pi, right? And then pi is 3.14, so 180 times 3.14 is about 565. So that's 565 square units. So that's the answer for the surface area. Hopefully that wasn't too confusing. Sorry, I messed up a little bit there. The next one's a lot easier. The next one is the surface area of a sphere. Is s equals 4 pi r squared. S equals 4 pi r squared, and then I have the radius being 8. So 4 pi times 8 squared. 8 times 8 is 64. 64, well, let's break it. I'll just take my time. 5 pi, 8 times 8 is 64. Right? 4 times 64 is 2560, I believe. 25.6. So 256 pi. And then that times 3.14 is roughly 804 square units would be the answer. Alright, sorry for the delay, I was helping the class. Alright, number 37 to 74 is we gotta find the area and the perimeter of a circle. So let's first write down what are the formulas. So we have perimeter, right? So to find the perimeter, since I only gave you the radius, is 2 pi r. 2 pi r. I know that's horrible. 2 pi r. And the area is pi r squared. So now all we have to do is just plug it in. Pi r squared. So 2 pi times r, which is 10. And for area it's going to be pi times 10. 2 pi is 20. Next is 20 times pi. And then 10 times... Oh boy, I made a mistake, didn't I? This is pi r squared. So r squared is pi times 10 squared. I didn't realize I made a mistake. And this becomes 100 pi. There we go. That makes sense. So now all we have to do is figure it out. 20 times pi, 3.14 is 62.8, or we'll just say 63 for the perimeter. And for the area is 100 times 3.14 equals 314. And that's the area. Alright, that's how you would figure it out. So what is the value of pi? 3.14, we know that. And then to add, I'll let you do the adding yourselves and the multiplying yourselves. 84 is draw a hexagon. How many? And then number 85. How many degrees are in a hexagon? Alright, let's do this together. Let me draw a hexagon with you all. Sorry. It's not perfect, but you get the idea. So that's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sides. Alright? So that's a hexagon. It has 8 sides. How many degrees are in a hexagon? Well, if I were to break it up into triangles, right? And this is a perfect shape. You know, each angle is going to be 60, 60, and 60. And once we count all these 60s in that amount, we're going to get a perfect circle. So a hexagon has 360 degrees, like a perfect circle. Alright, that takes care of that. Now, if one side of the hexagon is 6, what is the perimeter? Well, there are 8 sides, so all we have to do is 6 times 8. So this particular hexagon has the perimeter of 48. Draw a line. You need an arrow here and an arrow there. That's a line. A segment is a line with 2 dots at the end. That takes care of that. And draw a point. A point is just a point. And the rest, the Bible portion, you have to do in front of me. That concludes the geometry test. Not hard. I did this in 1 hour while the class was talking and making noises. So I expect the same from you all.